Hello friends and welcome back to your channel GATEquestionsECE. So I am back with next question on this series of random variables. The next question is question code 108. If random variable z, x1, x2 and x3 are related by z is minimum among x1, x2 and x3, then which of the following is true for the CDF of z? In this question we have to find out how the CDF of z is related to the marginal or the joint CDFs of random variables x1, x2 and x3. So let's see how to solve this question. So to solve this question, I will like to revise the question number 107. So in that question, it was given that z is minimum among x1, x2. So it was same question but for two random variables x1 and x2. So from the solution of question number 107, we know that the CDF of z, which we represent by capital F z for a sample value small z, is the probability that capital Z is less than or equal to small z. And this will be equal to probability union of two regions. One is x1 is less than or equal to z, union x2 is less than or equal to z. So similarly for three random variables x1, x2 and x3, we can write that if z is minimum x1, x2, x3, we can write its CDF. It will be equal to union of three regions. First region, same region, x1 is less than or equal to z. Second is same region, x2 is less than or equal to z. And union with third region, for third random variable, x3 is less than or equal to z. So I am writing this region as region A, this as region B, and this as region C. So we know that probability A union B union C is equal to probability of A plus probability B plus probability C minus probability A intersection B minus probability B intersection C minus probability C intersection A plus probability A intersection B intersection C. You can easily write this from the Venn diagrams. So we can write the CDF of Z. In this case, for three random variables, we can write it will be Fz of small z will be equal to, so probability of A. So it will be probability that x1 is less than or equal to small z plus probability of B means x2 is less than or equal to small z plus probability C x3 is less than or equal to small z minus probability A intersection B means joint probability that x1 is less than or equal to z and x2 is less than or equal to small z. Similarly, for B intersection C, we can write x2 is less than or equal to z and x3 is less than or equal to z. Similarly, C intersection A, we can write x1 or x3 is less than or equal to z and x1 is less than or equal to z. And for the last, A intersection B intersection C, we can write probability x1 is less than or equal to z and x2 is less than or equal to z and x3 is less than or equal to z. Now you can observe that the first term here, this probability is nothing but the CDF of x1, and second term here is the CDF of x2. The third term here is CDF of x3. Similarly, this term here, the fourth term here is the joint CDF of x1 and x2. Similarly, this term is joint CDF of x2 and x3. This term is the joint CDF of x3 and x1. And the last term here is the joint CDF of x1, x2 and x3. So we can finally write that capital Fz, the CDF of z, will be equal to the sum of marginal CDFs of x1, x2, x3 minus the joint CDF of all three possible combinations of x1, x2 and x3. So f x1, x2, z, z minus f x2, x3, z, z minus joint CDF of x3, x1, sample value z, z, and last plus the joint CDF of all the three random variables x1, x2, x3 and sample values z, z and z. So we can finally conclude that this is the relation between the CDF of z and marginal and joint CDFs of x1, x2 and x3. So the correct answer is option 4. So this is the correct answer. So similarly, you can generalize this result for more than 3 random variables. So I hope you have learned how to handle when the random variables are large in number. For minimum function, how to handle such questions. So I hope you like this solution, and I hope you will press that like button and subscribe to my channel for more such video solutions in future. So thank you for watching this video.